of PEEPanEIP, an educational video series where we learn about an improvement proposal, upcoming upgrades, and Ethereum blockchain basics. I'm your host, Pooja Ranjan, and today we are joined by Piper Mariam to have a technical deep dive into the Portal Network. The Portal Network is an ongoing effort to enable lightweight protocol to make the resource constrained devices be a part of the network, such as cell phone, laptops, or even Raspberry Pi. As per the GitHub repository, the term portal is used to indicate that these networks provide a view into the protocol, but are not critical to the operations of the core Ethereum protocol. To learn more on what Portal Network is and how it is going to help users, let's welcome Piper. Welcome to the show, Piper.
Hello, everybody. Thanks for having me, Pooja.
I'm super excited to have you on the show. First, I want to confess that I have been a big admirer of your work since I joined the Ethereum community. And this is the first time having you on the show. So generally, we ask our guests to provide a brief introduction and would love to hear when and how you joined the Ethereum community.
Cool. So I've been around for a while. I was in a really opportune job situation the moment that the Ethereum network launched, and it was a wide open blank ecosystem. And I've been around building things ever since. Lots of software in the Python ecosystem. Worked on a Ethereum client for a while, and now that has sort of evolved into this new thing, which we're calling the Portal Network, which I'm about to tell you about. But yeah, I've dabbled and had my hands in a lot of different stuff and learned a lot over the years, and well, here we are.
Wonderful. I followed your work and have watched you in meetings and events talking about and giving presentation. It's really exciting to know you more. And I'm sure not many people knew about it. So thanks for sharing. Moving on to the Portal Network. I understand you have got a presentation to be shared with our viewers.
I do. Here we go.
Yeah.
Alrighty. As I said, I'm Piper, and I'm here to talk to you about the Portal Network. There we go. Let's see. There we go. Cool. So here's a little roadmap for our talk. I'm going to tell you as just objectively and simply what the Portal Network is. We're going to go into the design goals that went into building this, like why are we building it and what are we building it for? Then we're going to do a bit of the deep dive part where I'm going to take you through what it would take for a Portal client to build and send a transaction using the Portal Network. I'm going to do some brief covering of just where the project's at and what's going on. And then we're going to do a little bit of a look ahead as to what I think comes next. Like as this thing gets live and as it becomes real, what happens after that? All right, so what is the Portal Network? The Portal Network is currently, it's multiple, 5 different decentralized peer-to-peer networks. They're all special purpose and generally designed to do one thing very well. So it's 5 different new peer-to-peer networks. This is not upgrades to previous protocols. This is not the dev P2P protocol that current Ethereum clients use. This is new protocols built on top of the Discovery v5 protocol that do these things. We've got 3 networks here: the state network, the canonical indices network, and the history network, which are special purpose storage networks that are designed there to store data and make it retrievable. And then we have these 2 gossip networks, the header gossip network and the transaction gossip network, that are there for their independent purposes. Header gossip for following the chain and transactions for broadcasting transactions. So in a simple sense, this is what the Portal Network is. It's 5 different networks that do very specific things and that are generally completely independent from each other. But the real thing here is that the Portal Network is an effort that's really focused on users rather than the protocol. Now, there's some confusion in terminology here because the Portal Network is a protocol and we've got this other protocol that's the Ethereum protocol. But the idea is that the Ethereum protocol is really focused on supporting the Ethereum protocol, right? It's about keeping full nodes up and miners and that stuff that's happening, the technical deep things as blocks are made and mined and all of that stuff. This network is focused on users, on the people who want to use the Ethereum network. And so we've really focused on that as our design goal because the 2 things have very different needs, and trying to do everything with one network hasn't worked super well. Another way to look at this is that the portal network is aiming to fill in a quadrant of this graph that currently doesn't exist, this pink smart car. Today, if you want to interact with the Ethereum protocol, you may either run a full node yourself, that's the decentralized and heavy corner of this graph, and they're quite heavy. We're looking at like 500 gigs of hard drive space, and that grows over time. You'll see some of my slides here probably say 400 gigs because they were made at different times. Or you can sacrifice on decentralization. You can go with the centralized and lightweight approach with something like Infura or any of the other centralized providers who also have access to everything that you do and can watch you do it. We're looking at filling in a third option here, an option that is both lightweight and sticks with the tenets of decentralization that we all care so much about, or some of us do at least. All right, so let's get into some design goals. This is the like philosophy, the motivation behind doing this. Primarily, we're looking at making things lightweight, right? We want lightweight devices to be able to interact with our network. And currently, that just isn't the case. You can get lightweight devices onto the network, but interacting with the Ethereum network and being on the Ethereum protocol as it exists today, the dev P2P protocol, is not a lightweight thing, and clients themselves are not lightweight either. Lots of CPU resources towards block execution, managing the transaction pool, and really just the general stuff that goes into syncing and all of those things, and lots of hard drive space allocated towards storage of the history. Again, we're looking at like 500 gigs of your hard drive going towards this. This is a very heavy thing. So for the storage piece, the way that we do this in the portal network is we're aiming for a network where things can be spread out among many people rather than one person holding all of this, one node holding all of the data, because that's how it exists today, is that full nodes on the network, they all hold all of the data. We wanted a network where that data could be easily spread around among all of the nodes in the network and that they could help share the load, right? Some of them can hold more than others, but in general, spreading things around. Another way to look at this is in this very informationally dense table that I have here, which the top row is the R value. I call this like the replication value. So how many nodes are storing in any individual piece of information. And in the left column, we've got number of nodes in the network. So if we say that a node takes 400 gigs of data to store it, then that upper left-hand cell there where it just says 400 gigabytes, that's what one node takes, right? But the portal network is really aimed at a very broad and wide adoption market, users, right? The people using the network. And that is a thing that should continue to grow and expand if we do this whole blockchain thing right. So if we get into networks with 10,000, 100,000 million users, and we're looking at replication factors of 20 nodes storing everything, we're sitting in really nice storage requirements for individual nodes. 100,000 nodes on the network, 20 nodes storing each piece of data. That's just 80 megabytes a piece. It's not a bad thing. So we're looking at building a network where we can spread this load out across lots and lots and lots of different machines. The other piece where we try to kind of spread things out is in the like CPU requirements. So currently, this is one thing that we kind of had to figure out how to fix in the dev P2P network is the mempool. So the mempool, to be a part of the current mempool, you must process the whole mempool. You need to be able to receive and validate and gossip and pass around every single transaction that is being passed around. And if you aren't that tall, if you don't have quite enough CPU resources to throw at that, you're not going to be able to be an effective member of that. Instead, we try to take this different model where we can kind of like let people, stack up on stack everybody up in a trench coat and make it look like it's one person or whatever. But the general idea here is that in the mempool, in the transaction gossip network, we want people to be able to sort of tune how much of this pie slice they care about. I would like to only process 10% of the transactions, but I will help with those 10%. And so this is one of the other design pieces that we focused on is the ability for nodes to show up with what they have and for that contribution to be valuable for the network. Another thing that we're looking at is UX. So we wanted a network where syncing, and we wanted to build a network that supported clients that didn't need syncing, because syncing is really bad UX. Having to wait like hours and hours or days for your client to sync before you can use it, that is why people use other stuff, among other things. It's just a really unfortunate UX, and it's fine for the infrastructure stuff, for the full nodes, for the pieces of software that run the core of the protocol. But when we're talking about user land, bad UX like this is just going to drive everybody but the most hardcore and dedicated users away. And so we've designed a network where the only thing that you need in order to do anything that you want to do in the network is the tip of the header chain. If you have a header that you consider to be the tip and real and part of the chain, that header gives you everything that you need to validate all of the rest of the data. So it is possible for Portal client, not just possible, but it will be standard, I believe, for Portal clients to be able to be downloaded, installed, turned on, and used immediately. Another thing that we're looking at is scalability, not the transactions per second type of scalability. That's sharding, that's a protocol thing. That's not what we're doing here. We're talking about scalability in terms of number of nodes that can be part of this network. Past efforts to do light clients, to do light protocol access were largely LES, which is the light Ethereum subprotocol. It's been worked on for years and it works, but the problem is that it depends on full nodes serving the data. And what has happened is that it hasn't been very reliable, because as you throw more nodes at it, those full nodes get overloaded, and it's not actually fine. The light LES has not provided like a reliable light client experience. If you look at sort of this, the simple graphic of centralized, decentralized, distributed, Infura is centralized, right? Centralized providers are centralized. LES is decentralized, but it's all clustered around the full nodes. And if you don't have enough of those full nodes, then there's not enough capacity for all the nodes that want to ask them questions about the Ethereum data. The Portal network has been designed in this distributed model, where there's not these nexus points of single nodes that are super important. Another way to look at this is to just think about how BitTorrent works. We've kind of philosophically tried to like take a cue from BitTorrent, this model where the more machines you throw at the network, the more powerful the network gets. That each machine that you add to it generally adds capacity, as opposed to being a leech on the network. And the last kind of philosophical design goal is that we had to be able to serve the JSON-RPC API, right? This is the foundational piece that, that just about every application in the Ethereum ecosystem is built upon, is the JSON-RPC API for interacting with the network. Current clients have a big database of data. Requests come in over whatever their JSON-RPC server is, and they serve a response by reading all this data out of the database. The Portal network's not incredibly different in the respect that a Portal client will get a JSON-RPC request, but instead of reading it out of a local database, all of the data necessary to serve the JSON-RPC responses is available from the network level itself without them having to have done upfront work. So they reach out to the network, grab a bunch of data, munge it a little bit, and give it back to the user as a response. All right. Does anybody have questions so far? Cool. Well, I'm going to move on. If you have something, feel free to wait for the next pause for questions. All right. So we've got a picture of what the Portal network is. It's a set of new peer-to-peer decentralized networks. We've got an idea of kind of why it is being built and what are the goals, why is it being designed the way that it's being designed. Rather than go through a bunch of slides that do like a bunch of deep dives and trying to like convey deep technical information, I'm going to take you through a practical example of building and signing a signing, broadcasting, and waiting for a transaction to be included. This is the rough shape of what this is going to look like. We're going to start in the header network, work our way through a couple of these things until we've waited for the transaction to be mined. Here we go. So the first thing that a Portal client needs to do is know what the latest header is, right? This is how we anchor all of the data. It has all the fields, like the state root for proving information as they get it back. And so this is what the header gossip network is for. It is for disseminating new headers as they show up on the chain. And then one of the other things that we needed to do was is that sort of same that you must be this tall to ride thing. The whole chain of history of headers is gigabytes in size. It's still quite large. And that's larger than we're willing to require clients to download. So we took a cue out of the Beacon Chain's design. They use this fancy thing called a double batched Merkle log accumulator. And with the combination of these and clients maintaining these locally, a client can follow the tip of the chain while discarding all of the history of headers and keep a very lightweight, while still being able to verify information from deep history. So the portal network does not dictate how you acquire the latest header. We leave a lot of room for this because this is one of the places where the UX gains can happen. On one far end of the spectrum, we've got the idea of just delegating trust to somebody else. You could just ask Infura what is the latest header, and in general, they have a pretty strong incentive not to lie to you. I'm not saying that you should do that. I'm just saying that it is one end of the spectrum. On the far other end, we've got the trustless approach, where you see a header come in over gossip, and then you trace the parent chain all the way back to Genesis. And once you've verified that, you have verified for sure, and this is still, everything I'm saying right now is still like anchored in the proof of work context. Things shift a little bit after the merge, but in general, these things hold. Is that in the but that trustless model is really expensive, right? Because you got to go download the whole history of headers. My expectation is that things are going to live in this middle model where things are a little bit probabilistic and we use heuristics and multiple data sources to verify things simply by reaching out to Etherscan and Infura and looking at what headers are being broadcast and doing some quick checks of like deep history to see if the things that are being broadcast are accurate. We can get a really strong indication that yes, the thing that we're looking at is the tip of the chain within a very short amount of time. So hand waving, we acquire the latest header, we have it, we know what the latest state root is, and this lets us dig into the state network where we're going to get our account nonce and then estimate the gas for a transaction and sign it. All right, this takes us into the state network. The state network is responsible for the storage of all and retrieval of all of the accounts and contract storage information. We've got a couple of mechanisms for bringing data into the network, as well as mechanisms for making sure that we can clean up old tree data that's no longer needed, so that we don't clog up all the storage with old intermediate tree nodes that just aren't necessary. But in general, the state network is for managing the state. It is the most complicated and the hardest of the networks. It was the hardest thing that we had to do, and pretty proud of the design. Excited to have some of you look at it. So this is a real like high level look at like what we do. So the idea is that all of these networks are DHTs. They're all Kademlia flavored DHTs, which means that they have like a 32-byte key space. And DHTs have this sort of topology to them, which means that nodes aren't just sort of floating around the network wherever, but they have this concept of like a location in the network that's dictated by your public key. And so what we do is we say all of the state data is mapped onto that key space somewhere. So for any piece of data that you want, you can figure out where in the key space it should live. And then using the DHT, you can find the nodes that live near that location, and they should have the data that you want, assuming everything works well. We're not going into anything about guarantees about data availability. There are absolutely states of the network in which data might be missing. The thing is that we can patch those things up very cleanly. I'm not going to get into those mechanisms today. For today, we're going to assume a healthy network. So we figure out where the account is where our account lives in the DHT. We go find the nodes that live near that, and we ask them for information about our account. Now that we have our nonce, we can kind of build a pseudo transaction that will run through a specially tooled EVM. We're going to stay in the state network, and we're going to estimate the gas for our transaction now. This works much the same way. Portal clients are going to need a specially tooled EVM that knows that when storage lookups happen, when any of the lookups into the state happen, instead of reading off of a disk like current clients use, it's going to read the data out of the network from somewhere. It's going to actually go look it up, pull the data back, verify the proof against the header, and continue with execution. This is what gas estimation is going to look like. You're going to have EVM execution, opcode, 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 and as soon as you hit something that accesses state, instead of fetching it from disk, it fetches it from the network itself. After estimating the gas, we're able to like fully construct our transaction and sign it, at which point we need a miner to include it in a block, which means we needed to somehow get it to miners. This is where transaction gossip comes in. So the transaction gossip network is also, all of these networks are DHTs, by the way, but the transaction gossip network is a little bit special. We add a little bit of like special flavor to the topology. I'm not going to get into too many details about that, but it's just the design that we've come up with that ensures or gives high probability of delivery to the miners. It is for managing the mempool of transactions. Individual nodes have control over how much of that pool they process. Full nodes might keep that number at 100% if they choose to be part of this network. Miners, front-running bots, arbitrage, MEV people will probably live at that 100% range. And then most of the clients are probably going to be sitting around 5, 10, 15, 20%, something like that, processing a small piece of the pool and then passing that stuff up to the bigger nodes. The other thing that we had to figure out here is mitigation against DOS attacks, because you can assign an infinite number of valid transactions, but the only valid ones that the mempool cares about are ones that are the next nonce, or maybe like the next 1 or 2 nonces, and transactions for accounts that have a balance of ether to pay for the gas. The way that we do that, and again, I'm not going to get into like the nitty gritty details here, but we just attach account proofs against the account alongside transactions. These can be benevolently updated by other nodes if they wish. Generally, the broadcaster will attach a proof to start off with, so this allows for that DOS mitigation without having to maintain a full copy of the state locally, which is otherwise necessary in the current transaction gossip network in the main Ethereum network. So the rough shape of our transaction gossip is this: is that you've got all kinds of different nodes in the network that manage different percentages of the transaction pool, and the transactions generally flow from the lighter nodes up to the full, minor nodes. It's a pretty simple gossip network otherwise. There's not a lot going on here. So our client, who has now signed our transaction as part of this network, has probably been processing, gossiping transactions the whole time. They take their transaction and they start gossiping it out into the network. Now that it's out there flowing around, finding its way to a miner who's going to include it in a block, we need to actually wait for that block to be mined to verify, yes, my transaction did make it in. One of the changes that may come about here is that it may be more conducive for clients to rebroadcast their transactions every once in a while, specifically to update their account proofs if they're sitting in the pool for a while. So in order to monitor for inclusion, we're going to go for the history network. This is the most boring probably of our networks, in that all that it is doing is storing the deep history of headers, block bodies, and receipts. It's also a DHT. We use a very simple map we map all of this data onto the topology of the network, and nodes that live near where a piece of data is mapped to are generally responsible for storing it. So to monitor for transaction inclusion, a client is going to do this kind of like simple flowchart. They're going to hang out in the header gossip networks as they see new headers come in. They're going to go retrieve the block body from the history network. They're going to scan to see if the transaction is actually present in the block body. If it is, great, their transaction got mined. And if not, they hang out and wait for another header to come in. That's the whole thing. This is just the simplest practical example of how the portal network was used. I'll point out that it did not use all 5 of the networks. We have this additional storage network here that we call the canonical indices network, that's responsible for storing the mapping from block numbers to the hash at that height, or transactions to the canonical block that the transaction was included. It just didn't fit into this example. Questions about that?
So just to get everything clear, all the transactions that are happening here are transactions that are getting mined on Ethereum mainnet.
Yes.
This isn't a mitigation solution at all. Like,
Nope.
okay.
This is a separate and secondary transaction pool.
My first is about the header network. How does it get DOS resistance in the proof stake world? Because you can't. I mean, doesn't everyone just need to be a light client essentially? And
once proof of stake lands, portal clients will also need to be beacon chain light clients.
Okay. But does the header network still make much sense in that world? Like, wouldn't you simply just?
It may not. We're just not
Right.
building with design dependencies that are far in the future. And the header gossip network.
I mean, is half a year far in the future?
It isn't here, and so it's not here. There's also like a header, the other thing here is that a client could just not even be part of the header gossip network. It is probably fine for most user land security stuff, users doing basic wallet interactions, for them to get their header information from centralized sources. It's not great. I don't want that to be the only thing that people do, but the header network is maybe the least important and most boring of like what's going on here.
Okay. Second question is about the state, this distribute hash table. How do you get anonymity in that? Like, how do you make sure that people can't track which state you're requesting or what you're doing or who you are?
They can.
Okay.
Yep. The real thing is that there's going to be lots of people storing each different piece of state. You're probably not going to get perfect views into what people are accessing, but you'll definitely see it. We've got some ideas for how to introduce some like levels of I can't find the word I'm looking for here, but
obfuscation.
Yes, it's not exactly obfuscation, but you know, if you can mine out a spot in the network so that you have like pretty reliable, you know, a pretty reliable picture of like who's accessing which, you know, the Uniswap contract or whatever, right? People might do that. One of the things we've talked about is just having the data slowly shift around the network. It doesn't exactly solve this problem, but it at least keeps there being individual actors who are constantly, you know, in charge of the same piece of information. But I think the real answer here is that this is not something that we have tried to design for. And this is kind of why I want more people to be part of this project, because we can't do all of this. Like it was, we had to like kind of draw some pretty firm boundaries over what we were going to solve for in this initial state and what we weren't. So there's a lot of room for improvement here, and I'm happy to engage with anybody who's got some ideas around how we can provide better anonymity.
Right, I see. Okay, and my last question is about the transaction network. So I'm not exactly clear on what it solves. Like, I mean, clearly, as you said, like whoever builds the blocks, and in the future that's going to be quite centralized actors, I imagine, because they are the ones who are able to extract MEV. For anyone else, it will not make sense to build blocks in the medium-term future. And so why do we need all these lower level nodes that you have in there that keep a smaller part of the mempool? What do they?
Them to have a way to submit transactions in a way that gets them to miners. That's like what it does. And I doubt right, and so this needs to be some kind of decentralized network that allows for transaction gossip to flow around and for the miners in that network to scrape those out and shove them into blocks. The reason that we had to design a different network is that we weren't willing to require that all nodes that participate process the full transaction pool. And so we needed a way for
But why does it
nodes-
need to be? I don't see why anyone needs to store anything at all here. Like, I mean, I guess in a
what would the
Well-
alternate model be for a very lightweight node to, in a fair, decentralized, peer-to-peer way, broadcast a transaction and get it to a miner?
right.
That's, if you have a different solution, I'm happy to hear it. But like, this is it's the thing that it's solving for. It's like why we have a mempool and transaction gossip in the main Ethereum protocol.
I mean, the practice might already very soon look very different in that, like, people right now already use like block relayers in order to like
Mhm.
get their transactions in without having MEV extracted and things like that. So
I mean, I'm this is another space where I'm open to ideas that improve this or that turn it on its side and slightly different. But in general,
Right.
this was designed in much the same way the existing transaction pool is designed.
are you
just
co-
provide a simple
considering that it is possible to like just add enough state proof, even in a pre-stateless world, to a transaction to make sure that it is a profitable transaction?
so the only proof that you need is against the account. You don't need anything with
Yeah,
execution.
exactly. Account and nonce, exactly. And that's even possible now, right? It's a
Yes.
few kilobytes. Yeah.
Yeah. It's
So
not
why
massive.
do any of the light nodes need to store any information? They
Well,
can just
they're not
forward it.
necessarily storing it. They're just holding it in memory and forwarding it around. This is not a storage network. This is
Right.
ephemeral stuff.
Okay.
You drop out,
Mhm.
clear it out, drop back in, acquire some new transactions.
Right. I see.
Cool.
Okay. Thanks.
All right.
So
Quick
I've
status
got
update.
some.
Oh, yes. by all
I've got
means.
some questions from Marius. Sorry.
Mhm.
Can you elaborate a bit on the TX pool design? The biggest issue with our TX pool is that it receives more than 1,000 transactions per second. Most of them
Yes.
replacements for existing ones.
Yep. So we just let you constrain the down to a percent. It's effectively a percentage. You say, I will take transactions within this range, basically, and you take the transaction hash, map it onto the 32-byte key space. And if the transaction is close enough to you within that, then it is then people will send it to you. And if it's not, they won't try to gossip it to you. So the idea is that you're publishing this sort of like range value that says, do not give me anything that's outside of this range. I'm happy to process things inside of it. And so the nodes are randomly distributed around the key space. And so the net sum of all of those nodes covers the full key space. And then the incentives of miners to get at transactions as soon as possible because they want to do MEV or they just want the fees from them or whatever, is one of the reasons why miners end up being part of this network. Maybe in the very early days, we're doing a relay between the dev P2P network, but the idea here is that now you will not receive the full, fire hose of the full mempool. You'll step into the network and you might say, cool, I want to tune this to the point where I'm only throwing like half a CPU core at it. And so you play around with that range number until the number of transactions you're receiving is being processed in the amount of time that you're willing to allocate towards it.
Also, are DDoS questions in scope for this, or does that fall under the?
Yes, but
kind
you
of
might
mechanism?
get a hand wavy answer.
Okay, so then basically, how do you prevent attackers from spamming a portion of the DHT to make state unavailable?
We don't. We are not tackling so one of the core things here is that this is not a consensus critical set of protocols. This is a protocol aimed at users. That isn't to say that people won't attack it or there won't be problems, but if somebody does that, then you just degradation in user land, and then we have a good problem to solve. There's sort of just some whitewashing of we have a problem and we have to solve it. But like if people are using this and DOSing a piece of the DHT degrades that user performance, then it means that we've built something that's useful and it's worth us attacking that design problem. It's just a hard design space. And again, we set pretty firm boundaries on what we were going to solve for and what we weren't. knowing that I needed, whatever, needed to get this thing up and live and real and show people, look, it works. And then we get to work on some of the harder problems of like dealing with some of those attack things. So I think the real answer there is there are definitely going to be ways in which this network could be attacked, probably. We're trying to take those into account as they get built. We've mitigated as many of them as we can, but there are just certain things that are hard problems, and I'm looking to get more people helping. Cool. All right, I'm going to jump on. There's going to be more time for questions at the end. So project status. Here's where all of the specs and all of the kind of coordination lives in the Portal Network specs repo. We have 3 legitimate implementations underway. Fluffy by the status team, Trin by the Snake Charmers team, that's my team in the EF, Ultralight by the JavaScript team and some volunteers. We're looking for supporting more implementations if anybody wants to join the club. I'd love to have a wallet embed. Somebody who wants to really take this and embed it in their wallet. That's one of the use cases that we really want to support. And if there's teams out there who want to do that, please talk to me. Progress-wise, we've got specifications for most of the networks. The ones that aren't specified are the simple ones that we generally have well understood and just aren't the priority right now. We're focused on building out the state network and the history network right now. The other networks will follow, but those were kind of the state network was the hardest, and if we couldn't do that, we couldn't do the other ones. And right now we are in the spot of doing client interop and starting to get towards a public test net where we're actually passing data around between these nodes. Cool. Looking ahead. So the future, I see this actually expanding. There's already people in the apprenticeship program looking at how we can put beacon chain data into the Portal network. Not into the Portal network, right? This will be a new network in the Portal network that's designed to hold the specific beacon chain data, right? It's either a special purpose storage network or potentially a kind of special purpose gossip network, depending on what you're looking at. There are people working on this right now. I think the Lodestar team has started looking at it, along with a bunch of people from the apprenticeship program have been kind of digging into this realm. So I see the Portal network expanding as things come along. The fundamental designs of like DHTs in the network seem really conducive to doing this stuff well. And I think there's another piece here, which I'll get to in a minute, where this stuff starts contributing back to full nodes. So one of the things I see coming is traditional clients. That's your Geth, your Besu, Nethermind, Aragon. Oh God, I hate when I start listing them because I forget somebody. I'm sorry if I forgot somebody. I probably did. But making those clients lighter. One of the things I've seen a number of the clients looking at doing is dropping receipts. Like, right, there's like 100 gigs of receipts, and if you drop the history of them, you give your users 100 gigs of space back. The thing is that the dev P2P protocol is not designed to handle clients dropping all of their receipts. It has it has an implicit requirement that all nodes in the network store all receipts. And over time, as nodes start doing this and nodes start trying to sync the historical receipts, they're going to start asking other nodes that claim to be fully synced for receipts. And those nodes are going to respond with empty lists because they don't have them. I would encourage all of the client teams to potentially come look at what we're doing, because the Portal network gives you a way to drop this data while still being able to serve it to your users or to other clients on the network if you want to proxy it into the dev P2P network. So there are opportunities here for traditional clients to lighten themselves in very simple ways. If any of you guys would like an intro starter in like how this is going to work, or any version of deep dive, ask me questions. I would be happy to do that for you. But I think this is going to be too tempting to not do it. Even if you don't jump in now and like work on us getting it up and live, sometime next year, we're going to have a network live that's got all of the chain history in it. And it just seems way too tempting to free up 300 gigs of hard drive space, or however much you want to free up, and just use the Portal network to get that data live on demand. Right? Like anyways. Another thing that I see the Portal network doing is just kind of like helping the consensus network, the full network, the full nodes and everybody else like that. So like SnapSync right now was built for a much faster version of syncing the state. And what it basically depends on is for you to make requests to other nodes across ranges of the storage space and for them to be able to give you those responses back very efficiently. It turns out the way that we're storing things in the Portal network is very conducive to asking a node for the range of the Ethereum state that they're storing, and they should be able to give it back to you in a very clean way. And not only that, but it won't be asking one node for a bunch of different ranges, but because we're talking about a network that's going to have 10,000, 100,000, a lot of nodes in it, you can do this at a massively parallel and concurrent rate, hitting, possibly thousands of light nodes to help a full node sync by asking each of them for their little piece of the state in kind of like a massively parallel fashion. Another thing that's really neat is one of the apprenticeship program people loves IPFS and or protocol labs and kind of the protocols that they've designed, which I only have loose understandings of. It turns out there's a really clean, I don't know if calling it clean is the right thing. There is a way, it's really hard to use general purpose storage networks for storing our data. I spent a lot of time trying to do that and gave up eventually because it turns out that the hash that they have, that the storage network uses tends to not be the hash that we have to reference the data that we need. Well, it looks like Protocol Labs solved some of this with IPLD, and one of the guys in the apprenticeship program has a proof of concept where he's serving the Ethereum data over IPLD using kind of like our native hashes and things like that. If anybody wants to collaborate with them on this, I know that Keenan would be very happy for that. This is a link to his GitHub. He calls it low Ethereum orbit. I really like the name. Good naming there. And the other thing that I think will be interesting is that if the network's big enough, we can build a global archive node that everybody can access. Geth archive nodes is somewhere around 10 terabytes. Aragon's like 1 to 2. So we're looking at like a 2 to 10 terabyte spread. Put that across 1 million machines, 10x replication, and you're looking at 20 to 100 megabytes stored a piece. If this hits a scale that's in that realm, it is very reasonable for us to store the entire archive state of Ethereum in the network, and that's a pretty neat thing. Evidently, that's all I've got. Does anybody else have questions?
So this is from Micah. Is the ultralight client being built to work in browsers, or is it targeting?
Yes, I did not cover that. So it's TypeScript, it's JS, but it is being built to target browser land. And we have this sort of proxy solution that has been prototyped and validated. That essentially is just, I'm not going to pretend it's perfect or that we've dug deep into it, but we have prototype Portal clients running in the browser, talking with regular Portal clients outside of the browser over the normal protocol, with neither of them, with the one that's not a browser one, knowing nothing different is going on. We use a proxy because disk v5 traffic is all encrypted. The proxy has basically just the same access to your information as your ISP would. It just sees encrypted packets flowing across the line. And this is something that it is not a fully well-baked solution, but it is a way that we can get Portal clients into the browser, and it looks probably viable is really is what I'm going to say. So like any of the wallets that ship Electron apps who might want to ditch their centralized infrastructure or give their users a way to interact with the protocol that doesn't go through that centralized infrastructure. This is sort of the other route for that client, the ultralight TypeScript client, is the idea of embedding it in an app like that. And then you open up, I don't know, the MyCrypto desktop app, and it just has a Portal client baked into it, and it starts running and connects to the network and does all the things that way instead of through whatever centralized infrastructure they're running. Any more questions?
Well, thanks for this nice presentation. I know it's technical and deep into it. I may have a couple of basic questions which are like for people who are planning to join the Ethereum network. In one of your presentation slide, you did mention about Infura, and it seems like Portal Network would be a better option for running nodes, but could you elaborate a little bit more, like how is it going to be a better solution than the third-party node providers?
I don't think it's definitively better across the board. There's going to be more latency overhead and things like that. So I will just be upfront that that like a wallet using Infura and a wallet using the Portal network, it's very likely that you're going to see a bit more just latency delays in fetching balances and looking up data, or like estimating the gas for very large complicated transactions. That those things you might actually see multi-second delays in fetching the data from the network. We have just generally run a bunch of back of the napkin numbers on like looking at standard Ethereum transactions, looking at how much tree data it accesses, and then doing some extrapolation on, okay, if we can look those things up in this many milliseconds, then we're fine, because it looks like we can do, you know, normal estimations for ERC20 token transfers and things like that within a second to a second and a half or something like that. So and then the other piece here is, right, that from a browser context, you cannot natively talk the protocol that the Portal network runs, right? We do require this proxy. So from a browser context, if you are doing a Portal network in the browser, you're going to be passing over this proxy. I don't know if that's going to end up being a completely clean and viable and just easy drop-in solution. I think it will be. I think that there's definitely a route there, but I need some smart people to come in and help figure that out. People who like working in browser land. I don't know if MetaMask wants to join the club, and I don't know if you're paying for your Infura access MetaMask, but this might be cheaper. So Infura is still going to be faster, right? If you want to like do big loads of stuff, they're going to be able to respond to requests faster. But for most things that users do, human-driven wallet interactions, those latency numbers are not likely to be a big enough differentiator for it to matter too much.
That's interesting. My next question is about the sub protocols. You mentioned that it is like different protocol, state network, history network, and all. And each of these network is designed to deliver a specific unit of functionality, and the portal clients will be participating in all of these networks. At the same time, these networks are designed to be independent of each other. Mm-hmm. So I'm curious, like, what's the upside of providing this independence?
So it would be very easy to write a command line transaction broadcaster that only knew how to talk to the transaction network, and literally you gave it a signed transaction, or it knew how to sign them, and the only thing that it does is just connect to that network and send transactions. Similarly, Portal clients that need to run on really lightweight places might choose to drop out of the transaction network if they're not sending transactions. They might choose to drop out of networks that they don't need to be a part of, and we want that to be an okay choice. We don't want the full gambit of functionality to be a required to be required. We want people to be able to make incredibly lightweight clients that do very special purpose things if there's value there. The other piece here is that it makes for upgradability and for the network to evolve in a much like nicer way, in that like when Verkle trees hit, we might ditch the state network entirely and just make a new one rather than trying to do some upgrade path. It's very reasonable to just say, old state network is old state, new Verkle state network is new Verkle state.
That's interesting. It's giving quite a flexibility to user to pick up whatever they want to. I have another question related to the beacon chain validator and portal network. So you did mention about that there can be a use case of having it a beacon chain light client. Mostly when we talked about this portal network, I'm considering it's mostly towards the proof of work.
Execution chain is our current target. Another place where we just drew hard lines and said, we're only doing execution for now.
All right. So my question was, by any chance, do we have any visibility of any other use case of portal network for that POS validators? If not present, maybe after the March?
There are a bunch of write-ups that the apprenticeship program people have done on kind of like how we might map the like what is it the beacon chain needs and how does that map into the portal network, if at all. There's some write-ups on that. This is not my area of fluency, so I can't like go into the details there. There's people in the R&D Discord who are working on this. In the light clients channel, you can find stuff there. You can find, but in general, the portal network is like it's pretty good. Like we have good primitives for building quite easy kind of plug and go networks for you have data that you want to shove into the network and have it kind of spread around everywhere, and then you want it to be retrievable. That's special purpose storage networks. So I think that we're moving towards a place where there's a gossip network that's in charge of gossiping around. Again, not my domain of expertise, but the light client gossip pieces that are needed for light clients to track the header chain. And then an actual one that's just about retrieving whatever piece of the beacon chain state you want to retrieve at any time. So I think the two of those make up the primary beacon chain functionality that's being ideated about how we map that to the portal network.
Interesting. I know we have 5 to 7 minutes left and I don't want to take up all the time. Anyone else, if you have any question, please feel free to jump in. All right. Yeah, I've got just one more. I wanted to bring it up in case we have time because it's not directly related to the portal network, but I'm hoping it may bring up some solutions. So last summer, I remember we had a long discussion on the client diversity at the All Core Dev meeting, and you published a blog post on snake charmers, I suppose.
Strong opinions about this.
That's right. Yeah. So I'm just wondering, like, I know that the problem has not been resolved yet. And the similar kind of situation is arising with the consensus client. Mm-hmm. Today, when we are discussing this portal network, I'm wondering, have you envisioned any change in the client diversity ratio with this?
Yeah. So my opinion about, so the reason before all of this, we tried to make a client called Trinity for the Ethereum network. And the original intent there was that this was a long time ago and there were no other clients coming. It was Geth and Parody, and that was it. Everybody else was gone. And I was like, okay, well, I guess I can try to solve this problem. And then we spent years trying to figure out how to be a client. And it turns out building a client is really hard. It turns out Ethereum clients are really heavy and hard pieces of software. It's hard. And your choices today are kind of try to be better at being Geth than Geth is, or maybe try to be better at being Aragon than Aragon is, right? Aragon's got this like sweet archive mode thing, and Geth's just like your like stock go for it client that's been at it for years. It's hard to be better at Geth than being Geth. They've had years to optimize what they're doing and the functionality that they expose. And it turns out that the protocol that Ethereum clients run on does not give you very much flexibility over what functionality you can build or not build. It says you've kind of got to build all of this functionality. And so what it means is that if you want to build a client today, let's say that you're going to come and like fix our client diversity problem, you are just going to have to try to be better at being Geth than Geth is. And there's not a lot of flexibility for you to be very different from what it does. We tried to build Trinity as like this, naively as this, like, we're going to build a lightweight client. Geth's heavy, let's be light. And it wasn't viable. It wasn't reasonable. And I don't think the client diversity problem gets fixed until clients are easier to build. And I think that the portal network makes clients easier to build, because I think it's going to make the dev P2P network evolve or change or something, because we're presenting all of the functionality that's present in the dev P2P traditional Ethereum protocol in a different way that's opt-in, that you can pick and choose which pieces of it you want to do, and in which and you can do it in lightweight ways. So by making it possible to write full nodes that are different and lightweight, my hope is that that helps change the execution client diversity problem. I have no good context to map this into the beacon chain client diversity issues. I think that those are slightly different issues, but anyways.
That's quite optimistic, and I'm also hoping that we get this diversity. Lately, we have been hearing about it a lot, and with a lot of education materials going out, I'm hoping that new users are going to choose some other clients and try to contribute in this section. In one of your slides, you already mentioned about some of the resources and the GitHub repository where people can go and follow the progress. While my research, I came across a website called portal.network. I just want to make sure this is in any way not related.
I do not believe, we do not have a website or a public presence, or if it looks marketing and pretty, it's definitely not us. We are working deep at the protocol level right now. I think it's not surprising that we've name collided with some people out there. But here we are with some branding that's stuck, which is the Portal Network. So I think we're stuck with it. Hopefully we can out-brand them or something. I don't know.
Well, I thought it's important to mention it because some people may get confused.
It's not us.
Related. Yeah. Yep. Thanks for clarifying that.
Yep. We have a dedicated Discord for anybody who wants to join. The specs repo is there in the slides. You can find it once the recording's posted. And yes, if anybody wants to get involved in this, come talk to me. I'm super happy to have you.
Thank you. Thanks once again, Piper, to share the presentation and talk about the Portal Network in depth. I'm hopeful this information is going to encourage many new users, especially the student group, to join the blockchain technology and find their way to contribute to the Ethereum network. On this note, huge thanks to our YouTube viewers for watching PEEPanEIP. I know we didn't actually discuss an Ethereum improvement proposal, EIP, but at least we adhered to a new acronym for PEEP, that is Peers Early Education Partnership. The vision of this, the vision of this series is to provide information on what's coming up on Ethereum blockchain, and I hope many of you may have learned something new today, and you would like to share it with your peers. So people extend your support by sharing this video link with people interested in learning about the Portal Network. The guest Twitter handle, slides, and other resources on the topic is added in the description section. Should you have any question, drop in the comment. We'll be back with another interesting topic for you. Till then, keep watching and keep sharing your love with Ethereum Cash.